Hello there, Wildcats. Welcome to your Algebra 1 class. And we are going to discuss in this video about geometric sequence. And you have already an idea about a recursive formula and explicit formula. And we'll just go over with those. And we'll be reviewing also the arithmetic sequence that we discussed first grading, I think. All right. Our objective, guys, is you will have to find the explicit and recursive formula of geometric sequences. And we are going to translate between recursive and explicit formula for geometric sequence. And then we have to construct exponential functions to represent geometric sequence. Um, because we are in the unit of exponential functions, so we are going to relate what we already know about geometric sequence to exponential function. Our essential understanding for in this video is make sure that your geometric sequence or number sequence in which each term is related to the next by a common ratio. They can be represented by recursive or explicit formula. Exponential function can represent geometric sequence. All right, our new vocabulary is about for in this video is geometric sequence. So let's jump into identifying arithmetic and geometric sequence. So I'm going to give you two examples here. All right, so let's identify. So this is my two example here. So let's identify if this two are an arithmetic sequence or a geometric sequence. All right, by definition, a geometric sequence is a number sequence in which each term after the first term is found by multiplying the previous term by a common ratio. So geometric sequence, they have a common ratio. So we're going to look at letter A, if it is an arithmetic sequence or a geometric sequence. So let's take a look at if they have a common ratio, meaning get the second term, divide it with the previous term, get the third term, divide it with the second term, and so on and so forth. And you have to make sure that they have a common ratio there. All right, so let's take a look at this. I'm going to get my, sorry about that. I'm going to get my second term here and then divide it with the first term or the previous term. So I have to divide 2 divided by 3, that is equal to 2/3. Okay, so how about 4/3 divided by 2? So 4/3 divided by 2 is also equal to 2/3. Okay, 8/9 divided by 4/3, so 8/9 divided by 4/3, which is also will give us 2/3. So as you can see, there are now common ratios here. So for the last one, we have 16/27 divided by 8/9. That will give us also 2/3. So the common ratio here, the common ratio is 2/3. Therefore, we consider this one as geometric sequence. Okay, why we consider it? It is based from the definition of geometric sequence. It says there that if you found that you have a common ratio. All right, so the second one, is this one an arithmetic sequence or geometric sequence? A while ago, geometric sequence, we said that there is a common ratio. But for arithmetic sequence, they need to have a common difference. Okay, they need to have a common difference, meaning if you subtract the term to the previous term, then they have the same difference. So this is my second term, 4.5, and I'm going to subtract that with the previous term, which is the 3. It will give me 1.5. Now, if I'm going to do that, the same process to all of those terms that I have there, if they will give me 1.5, then it is considered to be an arithmetic sequence. So 6 minus 4.5 is equal to 1.5. 7.5 minus 6 is equal to 1.5. and then 9 minus 7.5 is equal to 1.5. Basically, this is point, guys. Basically, the common difference here is 1.5. Therefore, we consider this sequence as an arithmetic sequence. Now you see there the difference between geometric sequence and arithmetic sequence. An arithmetic sequence, they have a common difference, meaning you subtract the terms. Geometric sequence, they have a common difference. Okay, so that's the difference between geometric and arithmetic sequence. Okay, now let's go and have this connection with our exponential function by writing a recursive function. So we have to write a recursive formula for a sequence. So the question here is, what is the recursive formula describes in the geometric sequence 8, 12, 18, 27, and then 40.5? We all know that in the previous discussion that we have about recursive formula, we all know that when we are writing a recursive formula, we have a sub n, and it's the number term is equal to the your r, which is the common ratio, and then we multiply that by a sub n minus 1 below the subscript a sub n minus 1, and then your a sub n minus 1, that is your previous term. Okay, so first is we have to find the common ratio. So find the common ratio first. Find the common ratio. Okay, so we have to find the common ratio. I get my second term, which is 12. I'm going to divide that by 8. That will give me 3 over 2. 3 over 2. 18 over 12, it's the same. 3 over 2, it's by 6. And how about 27 and then 18? That will give me 3 over 2 also. And then 40.5 divided by 27, that will give me 3 over 2. So therefore, the common ratio that we have is 3 over 2. Okay, and then we because we already have the common ratio, we can now write your recursive function there, or recursive formula. So I can now put there a sub n is equal to the ratio, plug in the r is equivalent to 3 over 2, and then we multiply this one by the previous term n minus 1. All right, that's how we do it. So the recursive formula is a sub n is equal to 3 over 2 times the previous term with the initial condition that make sure that your initial condition is that the first is we have 8. So there you go, how to write the recursive formula for a sequence. So in this one, we have the formula, and make sure that you have to follow the condition that the first term there is 8, because that's the initial number there. All right, so let's proceed with the next one. Now in this example, we'll be using explicit formula. But the question there is that, Mr. What is the difference between recursive formula and explicit formula? Your explicit formula directly calculates the term in the sequence that you want. Okay, so let's say I want to see, or I want to solve for the 10th term. Okay, basically in the previous example for recursive formula that we have, it's the same example that I put here for our explicit formula. So you can see explicit formula is what I have said. It directly calculates the term in the sequence that you want. So if you want the 10th term, just like in my example, we will be solving that. And if you want your 20th term, so you can solve that using explicit formula. However, okay, the difference that in recursive formula, it calculates each term based upon the value of the prior term, meaning you can solve the 20th formula of this sequence if you don't have the previous term. Okay, All right, just to simplify that, for explicit formula, you don't need the previous term. Okay, you can just solve the next whatever term that you want there, the 10th term, the 15th term, the 20th term, or the 100th term. But for recursive, you really need the previous term to solve for the next term. Right? So let's solve this one. Explicit formula can be written as a sub n. Okay, so that's the difference between recursive and explicit formula. A sub 1, which is your first term, and then r, which is your common ratio, raised to n minus 1. Okay, so the first term here is identified that your a1 in this given example is 8. So I'm just going to plug in, let's say the common ratio first. Your r is just like what we solved a while ago. It's 3 over 2. You just plug them in. Let's say I have the explicit formula here is a sub n, 8 times the common ratio, 3 over 2, and then n minus 1. Okay, n minus 1. This is the recursive formula, or no, it's not recursive, I'm so sorry, explicit formula that we'll be using now, because the question there is where they're asking us to solve for the 10th term. Therefore your n here is equal to 10. Okay, so I have a sub 10, okay, is equal to 8 times 3 over 2 raised to 10 minus 1. Basically, 10 minus 1 is equal to 9. So a sub 10 is equal to 8 times 3 over 2 raised to 9. And using our calculators, we'll have the 10th term was equal to 307.55. So the 10th term of this sequence is 307.55. All right. So that is the difference between recursive formula and explicit formula. Okay, let's go to the next one. All right, now that we already have an idea about geometric sequence and we already have an idea about exponential function, we are going now to make connection of these two. So the number of subscribers to a blog double each week. How can the trend in subscriber be modeled? So let's just make a model of this two. We can actually make a model for geometric sequence and exponential function. So the initial amount here, it's 5 subscribers. So the number of subscribers double each week. So an exponential function models the situation. So the initial number is 5 subscribers, and that the number doubles each week. So I can put there that we know that your exponential function is can be written as f of x is equal to a times b raised to x. And we know the common ratio, and we know the initial amount. So f of x is equal to a is 5, and then the common ratio is 2 because it says they're doubled, and then it changes every a given period of time x. So x is the number of weeks since the block started. Consider the week it started week 0. So this is the exponential representation of the problem. We can also represent this one using a geometric sequence with an initial value of 5 and a common ratio of 2. So we can put there a sub n is equal to a1 times the common ratio raised to n minus 1. So if you will notice, I made use of explicit formula. So we have a sub n, and we said that the initial amount is 5, and the common ratio is 2 raised to n minus 1. So this is the geometric sequence formula that we can use. So the number of subscribers changes by a constant ratio. So both an exponential function and geometric sequence can model this situation. All right. Okay. So that's how we make connections with geometric sequence and exponential function. So as a review of what we discussed in this video, so we have the concept summary, we have the explicit formula, and we also have a recursive formula, and making connection with exponential functions. So if you have any problem, guys, if you have any question, just let me know, and I wish you can join us with our live Zoom meeting for immediate feedback and you know um, more detailed. And if you have any question, we can answer it immediately. Thank you, guys, and we'll see you in the next video.